Hi, in this video we're going to make some examples of linear approximation. Now, for the first example, we're going to estimate a given value by using a linear approximation without any computational add. We have this exponential to minus 0.01, and so of course it kind of makes sense to use f of x equals e to the x, right? And so we're trying to approximate my f of minus 0.001. Now this number is kind of close to 0, right? It's super close to 0. So we could use a equals 0. And so if we can use a equals 0, well, let's compute what we need. We have f prime of x is just going to be e to the x as well. And we have that f of a, which is f of 0, is just going to be e to the 0 is 1. And f prime of a, which is f prime of 0, is also going to be e to the 0, which is 1. So now, if you remember, the formula for the linear approximation is L of x equals f of a plus f prime of a, x minus a. So if we're going to do our linear approximation for the exponential function with 0, then we get that L of x is equals f of 0 plus f prime of 0 times x, since a is 0. And so in this case, this is 1, and this is also going to be 1, so we get that L of x is 1 plus x. So now if we want to approximate f of minus 0.001, what we're really doing is approximating e to the minus 0.001, and that is approximately L of minus 0.001, which is 1 minus 0.001. Okay, and so of course this is going to be like 0.99, and then you can kind of compare later if this value is actually close to what you're supposed to get with e to the minus 0.01. But this will be the process of the approximation. Now, on a secondary example, on the first video we actually talk about using the function f of x equals sine of x, and then we were saying, well, what happens if we make an approximation close to x equals 0? What is the line that we're going to get? And then because we weren't doing the example in there, but mostly stating what it was, then we concluded that L of x was equals to x. This is essentially because f prime of x is cosine of x, and so f of 0 is 0, and f prime of 0 is just 1. So we create a linear approximation that is going to be f of 0 plus f prime of 0 times x minus 0. And so that's just 0 plus 1 times x. And so this is where I get that the linear approximation is x. So now if I want to use this for approximating a given value, let's say I want to approximate sine of 0.01, then I can approximate this by using this linear approximation, and this is going to be actually 0.01 since I'm just plugging here. Okay. Alright, that's a couple of examples in the linear approximation.